Okay. Okay. So those are some intro comments. I'd like to get on to a topic that is occupying us for the next bunch of lectures. We started last time test design. And you may remember that within previous classes, I had introduced to you a variety of types of testing. I had noted that there's testing that is black box in nature, meaning we don't pay attention to how the software is implemented, merely to what it's supposed to do. And we're testing it based on that. And then there's other cases which are, as we say, glass box testing. We know how it's implemented. We know what library calls it makes. We know, how it's sanitizing strings to prevent JavaScript inclusion. We know what algorithms it's using. And we try to take advantage of that. We know it's, on this certain framework, Node.js framework, and we know that it has these vulnerabilities or what have you, and we probe the security of it or what have you. So we have these two types of tests. And for both of them, we have needs to come up with test cases that are very specific. Testing is a great thing to talk about. We're going to raise the confidence that this program is working or spot errors. But at the end of the day, what really makes a difference in terms of running tests is you actually need to have specific test cases. So imagine you have a UI, right? It's on a phone. It's on a phone, and there's a bunch of things you can do from a given screen. You can enter things in these edit boxes. You can press these buttons and this link. From the perspective of that screen, or the perspective of a web page, there's certain things you can enter that should elicit, certain responses, right? Certain things you should enter that are illegal that should issue an error condition, an error message, or a warning. A failure to validate a field, and it highlights that field as needing to be corrected or what have you, right? In other cases, what you fill in is legal and it needs to do the right thing with it and maybe go on to the next step or what have you. This is when I'm talking about concrete test cases. I'm talking about specific inputs you give that should have specific outcomes, right? Or let's think you're testing a method, right? You're doing white box testing. So you're testing a method. Testing preconditions, does it satisfy the post conditions, right? You have a square root method and you give it a specific test case. You give it -1 as an input, or you give it 0, or you give it 4, or you give it 4.5, and you see particular outputs. Those are all test cases. Do you understand what I mean by test case? I'm talking about a specific set of inputs that should elicit a specific response, be it an error response or a response where it's able to carry out its planned job. Does that make sense? So the question is, look, we can't, when we're testing software, we can't possibly do all possible inputs. It's just not possible. So we have to choose our inputs judiciously. We got to choose them in a way that's sensible. They're broad enough to catch obvious likely bugs, but narrow enough that they don't take our time away from other things that need to be tested. The opportunity cost is not too high, right? So we need to judiciously test our software. We need to put in values that are more likely to find bugs if they haven't been found yet, and yet do a small enough number we can spend additional time testing other things, right? So we're picking very carefully what things to test. And this whole issue that I'm trying to cover now is how do you, in the next few lectures, how do you come up with the test cases, the specific instances of what to test to exercise the software well, but in a way that doesn't have too big an opportunity cost. That's the whole idea here, right? Does that make sense? Do I have to yell it louder? So I have a lab through the roof. I should ask them, like, So I'll tell you a story. So the first lecture I ever gave, this is the first university lecture I ever gave. It's actually in MIT's Grad School of Engineering, and it was in one of these buildings where they have floors that are designed for machines. These are buildings built in the in 1916, and the floors I think are 2 foot thick concrete, okay, beneath the tile or what have you. And I went up. So I had some colleagues who were interested in seeing my lecture, and they said, you know, we might drop by. Don't be freaked if we come in, because they want to see me teach a new thing upon the world. Yeah, this is when things got really bad at the world, right? almost. So anyway, they told me might come in to see my lecture, and so I was expecting them. So I went up. I was really nervous. I gave this first lecture, right? I gave this first lecture to people just like you. And I felt it went pretty good, but I never saw anyone come in. Honestly, I was a little bit let down. I would have liked if people could see, because I felt really good about the lecture. So I went down and I saw my colleagues who were located not far from there, downstairs. And I said, yeah, I gave my lecture. And they said, yeah, how did it go? I said, it went really well. They said, yeah, we thought so too. I said, what do you mean? I didn't see you. Were you standing outside the door? They said, no. We just heard it through the ceiling. I said, just no way. Just no way. They said every single word we could hear. They said it was a good lecture, too. And I couldn't believe it. But then many years later, when I was consulting overseas at a very large office building. And I was providing training associated with the software we were doing. And later that evening, people told me the entire floor of the building heard my lecture. They heard my teaching. So I guess 2 feet of concrete, yeah, I could probably go through it. That and a bagpipe and electric guitar, right? Okay. So I don't think we need to raise my voice louder. I know you'd like to see the guitar next, but that won't happen. Okay, so ladies and gentlemen, we started to talk about last time about equivalence classes and boundary value testing. What was the idea behind equivalence classes? What was the idea here? So suppose we have input. Let's think about input for a particular case. Imagine you have a system where you enter a date. Maybe it's a date to start with. To simplify it, maybe you pick a date from a calendar, right? You pick a date from a little calendar or widget, right? All of you have used them at one point or another. And it's supposed to compute the previous date. Because maybe that's the date after, the semester ends, and it's supposed to, calculate the last day of the semester or something like that. Or maybe the day before, we have to get some processes underway. So what would be, if you wanted to test something as to whether it's working computing the previous date, what dates might you choose?
Beginning of a month.
Yeah, beginning of a month. Okay. So beginnings of month would be a really good one to choose. And why might that be harder? Just to be obvious. Why might that be a good thing to check? Because it's on the boundary, right? It's on the boundary between 1 month and the other. If you're asking about the previous day, it lies in the previous month, right? And we need to check that. What would be another good thing to check? Another type of case, besides the beginning of a month. That's one class. That's one equivalence class. Things that are beginnings of month. What's another one? Beginning of year. Yeah, that'd be pretty interesting. How about another one, just to continue the thought? Beginning of a decade, century. Okay, yeah, century would be eventually interesting. Okay. So those are some good ones. But is that all? What would be another one that would be particularly interesting? Let's again stick with beginning of a month. What month might be particularly interesting to try? March. Okay. Yeah, because February is a kind of weird month, isn't it? Aren't you glad it's over? Yeah. Because you're not quite sure, does it go with 27, 28 days? So that's something that you might want to check. So leap year, is it handling the leap year right? Now, if you only tested beginnings of months, including beginnings of years, decades, whatever, have you done enough testing? No. What other things might you test?
Valid.
Okay, so valid. I would say beginning of a month is valid, but what other examples of valid input? You're exactly right, Mahmoud. What other ones might you use? I mean, it's valid to say the date, I'm specifying is beginning of the month and what's the previous date, but what else might you try to do?
If like the month was numeric, would you want to try something higher than 12?
Okay, so good point. I asked you for simplicity to start thinking about, you're going more advanced, and probably that was what Mahmoud was thinking about as well, but let's imagine you just have a calendar widget. A calendar widget is useful precisely because you can only choose valid dates, right? I mean, that's, at least I think. I mean, I've never gotten a situation where like it dies, because it says like invalid, intruder, get out of here. So I'm trying to simplify it by saying, suppose you can only do valid dates. We'll come to that case next. Your name?
Marcus.
Marcus, yeah. But let's just think for cases where you validate. Is there something, in order to pass the red phase test, is there something else besides the beginning of the month we need to test?
Just do maybe 2 or 3 any day of the month, because the majority of the cases are going to be at that time, and you just show that it works for most cases that way.
Darn right. Good. So at least a few cases in the middle of the month, right? Okay. Good. So I like that. So what we're delineating here is actually equivalence costs. I don't know if you noticed. You said things that are the beginning of a month. I mean, is that just one test case? No, there's a huge number of possible test cases at the beginning of the month. March 1st, 2018. March 1st, 2017. March 1st, 2019. January 1st, 2017. These are all beginnings of months, aren't they? So there are many test cases that are fit into this so-called equivalence cost that takes the beginning of the month. And the thought is that, look, if one of them goes wrong, probably the others do. And that's why we often separate out like beginning of year from just beginning of months during the year. So I think actually what you want to do in terms of equivalence costs is say, okay, one equivalence cost is things that are not the beginning of the year, but the beginning of months later than January, right? Because if there's an error in one of those, probably there's an error in the others too, right? Let me flip it around. If we check one of those and it seems to work fine, maybe 1, 2, or 3, is there any use checking 100,000 of them? Probably not. I mean, the value from that is probably pretty limited, right? Of doing these extras. Okay, and then there's things at the beginning of a year. If you check a few years and those seem to be working, there's probably not a lot of use of trying to exhaustively check all years back to Julius Caesar's birth. Piece of paper. Oh, 90% confidence. No. Okay, so then we're saying things within a month. Those are kind of equivalence causes. There's a whole lot of things which are within a month. The point is pick 3 or 4 of them, 2 to 4 of them, and try some out, right? Those are equivalence causes. If it fails with respect to those, probably gonna show up for any one of them. And by the same token, if it works for all of those, probably it's gonna work for other dates within a month, right? So why test every possibility? You don't have that option. Okay? So those are some equivalence classes that we've specified, and we picked some up. Now suppose we don't have a nice little calendar widget, or suppose we're instead specifying dates to a function which is computing this. It's not through a UI, but it's a function. We pass in a date object into this function, right? Don't use Java date. Java date is bad. worse than Tinder. Okay, it's horrible. Actually, the Java date is broken. It's mutable, and it is highly problematic. Okay, and you actually want to use more recent Java libraries, and there were some third-party ones, but then with Java 8, they came out with a new date framework that's much better. Okay, the fact is that if you are testing a function now, you have to specify sort of dates to try to give it. Maybe you specify, let's say you specify month, date, year as a set of particular parameter values. What dates might you then start to check? It's no longer a calendar widget. What other equivalence classes might there be? Yeah.
Would you check localization? Different dates in different.
Okay.
files.
So good idea. In this case, I'm going to abstract away from that detail and just say you're just specifying month, date, year, regardless of your time zone or what have you. Just month, date, year. What other equivalence classes might you specify? Here we're not limited to only correct dates like we are with the calendar widget. It's not letting us force on it an illegal date. But what dates would we want to test if we have to specify, let's say, month, date, year as integers? What else might we want to check?
Just like anything that's invalid.
Yeah, anything that's invalid. And tell me how something can be invalid.
Say, like if the user was inputting it and they put the year it's supposed to go.
Okay, I like that. So cases where, let's try to be concrete about the equivalence classes. Okay, so there might be cases where you said they put the year where the month would have to go. So cases where the month is outside the range 1 to 12, for example, or cases where the day falls outside the range 0 to. Okay, now this is, you should be realizing this is getting a little bit more complicated. Yeah, you have to look at the month as well. So the equivalence classes here are not something that can be specified for each input in isolation, like day. You have to consider what's valid for the day, you have to consider the month, just like Mark has said, right? So if it's January, you can specify for the day between what? 1 and 31, yeah. And if it's, April, you can specify between what? 1 and
30.
Yeah, 30. Good call. 1 and 30. But you see where I'm going with this. Now suppose it's February. Okay, now what do you got to consider? Month and year. So here the equivalence classes will be actually rather more involved, because you're going to need to consider, ones where, for example, the date is within the month, say 28, but it may be for a year it's inappropriate or what have you, and vice versa. Or in cases where you're specifying a month and year that where the date is very regular for the month, and so it's always 0 to say 31, regardless of year. But you want to be able to specify values outside of that range, say 32 or 31, where that month does never have 31 days, right? It's April or something like that. So in short, ladies and gentlemen, we need to be thinking about sort of classes of things we want to test that are kind of similar to one another. And one would be, okay, it's February and the date and month are inconsistent with the year because it's a leap year, what have you. Another is a case where the month and the date are incompatible because the date is impossible given the month. It's April 31st, right? There might be other cases we want to try where that by the normal rules of leap years, it would be fine, but because it's at the end of a century, there's this special rule that applies. So those are sort of equivalence classes, but you're going to want to have error conditions as some of them and valid ones as others. And you want to make sure it alerts you to the errors, like it throws an exception or otherwise indicates returns an error code to indicate there's an error. And in other cases, it should work okay, right? So these are different types of inputs that you might try. And you want to try a few of each one, but not exhaustively. You can't possibly exhaustively check them. So here, we're trying to come up with these equivalence classes based on the inputs, and they're not always independent of each other. They may be coupled, just like what dates are valid depends on what month it is, and in fact, sometimes what year it is. Does that make sense? Okay, so if you had a screen which had these inputs, or you had a function which was taking, for example, values for square roots, you want to try different values, some of which lead to legal results, some of which lead to illegal results, but you want to sample from these classes at least a couple times each to make sure that it seems to be working properly, right? And I have some examples here, you know, on sort of valid equivalence classes, and then equivalence classes of valid input. So, okay, you have a number that has to be between 1 and 99, and here, you know, people enter 0, they enter something greater than 99, or they enter negative numbers, they enter letters. These are all different things to try. Could you imagine a case where a bug creeps through, or you might not think of it as a bug, but if the system's not as helpful as it could be, and it falls short of what it should do. For example, where maybe it catches all of the first 4 of these, things where it's 0, things where it's 99, an expression that was suggested last time, negative numbers. But could you imagine it, for example, not correctly giving an appropriate error message for letters? You know? Maybe it needs to give an error message that's helpful for letters. Maybe they enter I instead of 1, or L instead of 1, right? They think it's a 1, and they enter it, and it's not a meaningful error message. So, you know, here you want different. These are different equivalence classes. If it handles one, it probably is going to handle the other. And then a test case would draw a particular 1 or 2 or 3 of these and test it out. Does that make sense? Okay. So how do you recognize the equivalence class? Well, they test the same condition. If one test finds a bug, probably the others will as well. You know, do they cause the same internal operations of the system? They get handled in the same way. They lead to the same set of library calls. They lead to the same basic types of output or what have you. These would all be reasons to think, okay, they're probably in the same equivalence class. If we test a few of them, we're okay. Do you understand that? Okay, now, yeah, so here, you know, my tips are, so I want to see these for your programs. I want to see these for your forms, your screens, your web pages, your user inputs. I want to see you make sure you tested it out with respect to these. So, you know, consider looking for equivalence class for each input field and form. It may not be independent of the others, just like date and month are not independent of each other. Consider equivalence classes for invalid inputs, not just for valid. How could this be? What are the ways this could be bad? It's left empty. It's too long. It's in a non-Roman font. It's in a different language. You know, it is accents. I mean, there's many different ways it could be bad. And you want to check these different ways because some of them might be handled while others are not, right? They're in different equivalence classes. You might want to organize the possible outcomes in a table or outline or a tree of how it handled. Look for ranges of values that you know should be handled in kind of similar way, or group membership. Things that calculate to the same sort of value. and try to identify sort of identical output events. So what things lead to the same identical output? We only test a few of those, okay? So you can arrange it in a, an outline form where here for enter a number, you have these different cases, or in a decision tree form. So, okay, if this is the case, under this conditions, do this, etc. And you're going to want at least some test case where they're 25 or younger, maybe 1 to 3 of them. Some when they're 26 or older, they have 0 claims for each of those. At least for this case here, to make sure this is handled properly, we need at least one or a few, hopefully, cases where we have one claim, the person is 25 years or younger, and we see, okay, does this properly get undertaken as the action? When I said test case, I mean particular things, like maybe one they're 18, maybe one they're 17, one they're 19, and those are all would test this one case and just make sure it's working. Does that make sense? Yeah, this idea that, look, we have different ways the system behaves. There's different equivalence classes for how the system behaves. Under one condition, it does one set of things. Under other conditions, it does other set of things. We want to make sure we exercise each of these. Could I stand before you and honestly say that I've tested this if I haven't tested each of these possibilities? I mean, seriously, I mean, here are 7 different variants, each of which should do a different thing. If I say, well, I've kind of tested 1 and 2, and I'm confident it works, would you say there's a high reason to believe me? No, you might throw tomatoes or something. So, you want to have confidence that these have been exercised, but you don't want to go overboard. You want to have at least a few cases of each that you try, right? Yeah. Suppose this involves manual input. Suppose it's Oculus. Maybe there are certain gestures that are illegal. Maybe there are certain things that I can't do outside of a boundary of the given area, right? There's certain things I try to do when there's no points shown. Certain things I try to do when all points are selected, I try to select another one or something like that, right? I try to do certain illegal actions as well as legal. These don't have to be undertaken automated, although it's great if they can be undertaken automated. And you could create a decision tree for this, right? Under these conditions, we try this. And so, look, to pass the red face test, you want to have at least one test for each of these because they yield different outcomes. Does that make sense? Yeah, Malcolm.
So I'm not sure if I'm actually understanding this correctly right now. So you had on the right-hand side
this one
was a decision table.
This one.
Yes.
Yeah.
Can we actually conclude that from the coverage of the files?
No.
Because, for example, we did exercise all of them. If we hit all of the lines, we mean we actually did get all.
Not necessarily, because it's a good question, and it brings a reflection, rightly so, on what does coverage give you. Okay, we're going to be talking about that in coming lectures, but let me give you the skinny on it, okay? The skinny on it is that coverage tells you which statements are reached, okay? These are not necessarily reached in different statements of the program. They may be reached because of, with the same basic statements, but looking up values in arrays, for example, that are different values. They're looking up each of these in an array. They take the person's characteristic and number of claims, and they hash it in a hash table to a variant number, which is used to look up the values to use for each of these. Same statements that are exercised by, say, variant 1 and variant 2 and variant 3, but that doesn't mean that testing variant 1 will give the right results, because it may be that the contents of some of those tables are coded incorrectly. They have wrong values in them. The hash table maps these things to the wrong case, or the result for the premium increase. Someone said it was 4,000 for case 5 instead of 400, and if you don't test it, who is going to test it? You don't want someone to be handed a letter, especially yourself, which says that your premium is has increased by $4,000, right? Because you're 25 years or younger and you have 2 to 4 claims. Right. That would not be a happy thing. Would you agree with that? Yeah, so it's not necessarily going to be determined by coverage because they won't be in different statements, okay? They might not be in different statements. They could be in the same set of statements, just different values of the data that they're using. Does that help?
Yes.
Okay. Other questions about that? Okay, so ladies and gentlemen, these are equivalence classes. We pick, for each equivalence class, we pick a couple items that we want to test. A couple particular concrete cases that will be within this circumstance. And ideally, you'd write them down as test cases, which could then be automated, and it's testing it with a 17-year-old, and it's testing with a 19-year-old, and it's testing it with a 23-year-old. But those might not be actually the best values to test it with, even within that equivalence class. If I were to test variant 1, what might be a really good age to test?
0.
Okay, 0, yeah. The driving baby. Okay, so yeah, so I might test things there. What might be another big one to test though? 25, yeah, because this says explicitly 25 or younger. But there's this thing called an off by 1 error. Have you encountered that? Who has not encountered that? Okay. I think we've all encountered that. We're off by 1. It's a very common error. And one of the best things you can do is look at boundaries for these reasons. And this is the motivation for boundary value testing. You test things at the boundary of 2 cases, okay? So you're testing things that fall between this case and this case, right? You're testing 25, right? Another one you might want to test is 26, right? Just to make sure that this boundary is captured properly, right? I mean, after all, in terms of the equivalence class, for variant 2, I might choose 52, right? Or I might choose 30, 31. But from an equivalence class perspective, I have to pick at least a couple members. But what I'm saying is more than that, you want to pick judiciously cases within that equivalence class that are particularly likely to find problems. And one of the most common types of problems is an off by 1 error. And so we pick things at the boundary, 25 and 26, right? We'll make sure 25 gives us variant 1, 26 gives us variant 2, assuming in each case we have 0 claims. Does that make sense? So this is not some ethereal thing. I want to see this in your program. I want to see this for your projects. Well, maybe I'll put it another way. I'm looking forward to seeing it for your project. I'm really looking forward to seeing you think this thing through, because this is what people do when they test software. They test out various cases that will exercise problems. Could you do this for a function which has some preconditions? Could you apply the same reasoning? Darn right you could. It would be a little bit different. Like if you're passing in pointers, you know, it's not, you're not dealing with a range of possible inputs, but a lot of the time we are, right? We're passing in integers, which are indices into an array or something like that. And so we want to make sure that it correctly handles the case when it's the highest value of the array, or that it flags cases where we're beyond the end of the array, or we've got a negative value, or what have you. And so we can again pick representatives of equivalence classes, and we can pick boundary objects. So with boundary objects, you often will end up working with these in the context of ranges, and you'll specify, say, the minimum of the range, and then you want to try minimum -1. Often it's into a different equivalence class. I mean, it is in the equivalence class, so that's why it's below the minimum. But you want to make sure it's not classified as this equivalence class, right? Because we're supposed to enter things between a minimum and maximum. Minimum -1 should not be part of this equivalence class. You want to verify that, right? And for maximum +1, similar idea. We want to try make sure that we haven't got a one-off error there. Now, often that will be the minimum of another equivalence class, but the point is you want to test these. And boundary value testing and equivalence class testing complement each other. I mean, often you think about the equivalence classes; they're defined in terms of maximum and minimum. You pick a few representatives from each, and you pick the few representatives to especially test the boundaries. Now, the boundaries are not always neat numeric numbers, right? They can be floating point numbers, double precision numbers, integers. Those could be nice numbers with clear sort of ranges associated with them. But suppose you're dealing with strings. So you've got this thing that takes the string input. What? So maybe it takes in this string and it lets you know if it contains a certain regular expression. If it matches a certain regular expression. And maybe it's a more complicated regular expression, so it's not just a single one, it's looking for a couple possible regular expressions. What might be strings you pass to it? I'm asking this because strings are not, they're not specified as ranges. You know, we don't have a neatly defined linear range of strings, right? It's not like you can say, well, okay, you can lexicographically sort them, but that's not generally enough to be helpful for thinking about this. So what strings might you pass out? Just something like that.
String with 0
Great. So it might be a string with that misses the regular expression, but I would argue we want to sharpen that even more. Okay, so it's missing one. We definitely want to have at least one of those. So it's a great example. But I would argue within that there's a few equivalence classes within that. Yeah.
It's almost a regular expression. Like it's something of like a space or
or
something.
Slightly off. Good. And we can think about slightly off in different ways. Like it's close to it, but as one more, like maybe it can match ... and you give it something that just has one dot, right? Or it's supposed to match ... but not ... and you give it ... right? And you see. What would be another thing where it might not include the regular expression, but you want to test it?
Strings.
Empty strings. Yeah, a string that's empty, right? Now, in Java, if you're passing it literally as a reference to an instance of string, what else might you give it? Null reference. Yeah. That's not an empty string. It's a reference to no string, right? But the same notion applies that these are sort of extreme cases, not in a range in a strict range sense, but they're extreme cases. You could think of them as boundary sort of cases in a certain sense. What other strings might you give it?
If there's an escape character, kind of with and without it.
Good. Yeah. With an escape character, is it properly handled? That with the escape character, it shouldn't be recognized or whatever the functionality is. How about another one? How if it includes more than one case of this regular expression? I mean, possibly that could go wrong. I mean, it's probably worth checking. It's more likely to go wrong than an arbitrary string, right? So these are good cases. How about something else though that might throw it off? So students in this class sometimes were really afraid of me because I would do unusual things with their programs. And one of the things that I most like to do was to paste other languages into it. So, I paste a Chinese novel into an input thing and just see what happens. It's a really interesting thing that happened. I remember a pizza ordering system, which I was able to get, I think I was able to order something like 99 vegetarian pizzas with ham topping, and they would cost negative price, so they would pay me to eat them. It was awesome, and I did it through sort of, I think, like adding them and then deleting them, and you could trick it into this thing where I think you could like if you deleted beyond there were none more, it would add in negative pizzas or something like that. It was great. So strings that are too long, strings that are in different languages, different fonts, or sorry, not different fonts, different character sets, right? So maybe it can only depend, yeah.
I was gonna say.
UTF, yeah, encoding schemes. These are significant things. Maybe it only allows up to 100 characters. But you know, when I was a young man, when I was a young man, we used to be able to assume that characters were the count of characters was the same as the count of bytes in a string. If there's this many bytes or this many characters, it is that many bytes, and vice versa. Right? It was a very nice assumption, and our programs come to count on it, like without asserting it, without saying it was just, of course, built into the program, right? And that ran into a wall when we started to have to include other languages, right? Where it wasn't so neat. You couldn't just live with 255 different characters plus 0, right? The null terminator. And so we started to have issues with that. And so maybe, for example, this thing is supposed to allow strings up to a certain length only, right? You can only specify strings up to, it'll only search for the regular expression of up to 100 characters in length. And maybe you find that actually it doesn't let you search up to 100 if you use strings that have other character sets. So maybe character sets like Chinese characters, it will only allow up to 50 because they require twice as many bytes to encode or something. Or maybe someone's using a size of operator in C to assess the length rather than something else. So in short, you can try various cases, and you should, because I'm going to try them if you don't sometimes, right? But more to the point, these things can happen. I mean, you know, in user inputs, odd things can happen. You have users who are not in the continental North America, right? And they use things, and they end up getting messages which don't work, or it gets crashes, or what have you. So test these things. They're not that hard to come up with cases, and it's a little bit fun. Okay, maybe you think I need to get out more, but I think it's kind of fun. And I would invite you to try it, okay? Try it. And see if you can come up with cases for these things. So often reason about the equivalence classes then points to the boundary values for them, right? It's an equivalence class. So I want you to think about this. So I'm going to say, I chose it. We did this example in class that was kind of similar, but I think we'll do this. So the next state. So suppose you had to pick out a next state based on numeric day, month, year. What would be good values to test for that? Think about this for next time, okay? For next state. Or arguments to give to strlen determines the length of the string, right? Or, well, we talked about square root. Maybe you can go light on that because we've already talked about it, but see if you could think of any additional cases you might want to give, okay? So think about what these equivalence and boundary values are for cases like this. But most importantly, think for your systems, which might not involve really neat, you know, edit boxes. They might not involve really neat, you know, sort of numeric pickers or drop downs, but more innovative user interfaces. What would be sort of equivalence classes to try? What would be boundary cases to try? What would be cases that if it handles this, it'll probably handle all variants of this? And what are the boundaries that you know you want to make sure it's getting right? Okay. So do you understand the principle here? Okay, great. Next time we're going to be, so we'll cover a little bit of comments on that. And then I'll go on to discussion of something called orthogonal arrays. And orthogonal arrays come up in the context of systems where we have many different inputs, and we can't realistically check all possible pairs of it, or all possible combinations of inputs. But what we can do is exhaustively test all possible pairs of classes of inputs. Okay, so we'll look at orthogonal arrays and take a look at how they can simplify cases where we have many inputs at the same time. Okay, so thank you very much, ladies and gentlemen, and I will look forward to getting you some comments tonight on your projects. Okay.